Welcome to the Automate Construction Podcast. We're joined today by Morten, Bove, CEO of Wohn Homes, building homes with autonomous construction using alternative materials. I'm really excited to talk to you today about your revolutionizing materials and methods. Thanks for joining me today.
Thank you. Thanks for having me. Will be a pleasure, I'm sure.
So how did you first step into construction?
Basically, I think it came actually for the idea or the wish to change how society is actually built as such about social inequality. That's where I started. I say, what is it that makes sort of social inequality? And to me, it turned down very kind of Maslow-ish, food, water, shelter. And I said, if I can figure out a way to provide shelter at an affordable kind of price, high pace, we actually come a long way about dealing with social inequality. That's where I started. I don't have a construction background at all myself. I come from, well, many things, but started with chemistry, chemicals in a big sort of English company, moved on to IT, moved on to design. Now here I am, a kind of full circle in many ways, using technology as a way, with a lot of material science inside, as a way to provide, sort of homes of high aesthetic quality. It's kind of full circle. It was not a career planning exercise, but it happened to kind of come out that way. So here we are into construction. Yes.
Fascinating. And materials is obviously really important, especially if you're trying to develop alternative materials. You're having to tread a lot of new paths that other people maybe haven't pursued or at least haven't applied in the same scenarios and technologies. So what was the initial vision for the material to use and the technology to use? Did one come first, the chicken or the egg?
Yeah, I think technology came first, actually, in many ways. I've always been fascinated by, 3D printing, additive manufacturing. As such, my co-founder came from the same place, you can say. And when we actually started working, with sort of trying to figure out, can we 3D print homes out of waste plastic, polymer, basically. And we tried and tried and tried. We did kind of okay, but it was not ideal. And then we started working, basically digging deeper into the material composition we're now working with, where you can say, we'll come to that, we can say the material which we are working with now, which really works wonders, this special formulation of sort of waste plastic, waste polymer, and waste wood. The magic lies in the waste wood and wood fiber, sawdust, basically. That's which we kind of put into the compound we're using. So it started with a kind of an interest, a desire to work with sort of 3D printing as a cool technology. We also had the idea of the design freedom in terms of aesthetically, but also so how to work with kind of forms and shape, also from a kind of static kind of perspective, design for strength and stiffness. That's where additive manufacturing really comes in very, very handy. That's where it started. And then from there, we said, okay, which materials are actually kind of useful here? The whole idea was to also having this very profound sort of climate angle to what we do, knock out CO2 of the construction as well, which meant we never as such looked as an example of concrete 3D printing. What we really want to use waste resources, have a very low carbon footprint of what we do, replace, you can say, the incumbent ways of doing homes, of doing construction. So we set up, you can say, some kind of barriers for ourselves or frame for ourselves. Within we really had to kind of optimize for doing what we do today.
Yeah, that makes sense. And can you dig a little more into the issues you saw with concrete and why you didn't want to consider that?
Yeah, well, the issue about concrete is basically, what comes before concrete, cement, and the huge carbon footprint of producing cement, which is, the problem, the issue with every construction as we know it today, being the traditional, having sort of concrete kind of panels, or if you like, with which we build, casting concrete foundation. And then, of course, we have 3D printed homes out of concrete again, which to me doesn't really solve the problem of reducing the carbon footprint of construction industry. So you say the whole issue about how do we fight climate change? How can we change behavior in the way we do things, the way we manufacture things? Takes up a lot of space in our thinking. And because of that, basic concrete was, from day one, totally out of the question of how to do things because of the huge carbon footprint of producing the cement to the concrete.
So you decide you want to print something. The technology kind of came first, but you start looking at printers and you see the concrete, and that's not for you. So
Yeah.
you determine you need to adapt your own materials, and initially you try to work with waste plastics, but that didn't go exactly how you wanted. What part of the waste plastics without the wood fibers was the problem, or the wood shaved?
That was the fact. When we try to build and print, large scale, big scale, the what happened with the polymer, the plastic, basically was it collapsed. We find it very hard to sort of keep a kind of a shape and form we were expecting to get. So because when you print with plastic, so large scale, it tends to collapse. We had a lot of warping, all the kind of stuff which you don't want when you manufacture. So and then we start looking, okay, how can we reinforce? How can we stabilize the print? And that's where we then start looking at wood waste. Again, sawdust, wood chips, basically, which is then kind of grinded and put into the compound. Also, the reason why we went this route was also if the mission is what it is to make affordable home modules, being sustainable at the same time. We had to also look for resource which was cheap and also infinite as such, which also kept us looking into kind of the streams of waste. The streams of waste plastic are crazy bigger. The world produces 270 million tons of plastic waste a year. So we produce 300 million tons of plastic. 10% is kind of upcycled, recycled, regenerated of some kind. Remaining 90% is burned, put into landfills, trashed, basically, which is absolutely bonkers. That's why we looked into this field. Okay, what can we actually? There must be something here. We have a lot of material here which is just trash. Can that be turned into a resource? So again, this frame we've put up around ourselves, within which we should operate to kind of fulfill the kind of the mission we laid out for ourselves.
Yeah, it's interesting. Intrinsically, I feel like wood belongs in houses because it's a nice material to the touch, and it's kind of something that humans have used for building for a very long time, as opposed to concrete is more kind of sterile, and it's hard, it's cold, but you didn't put the wood in for the same reasons I'm describing. You put it in for buildability in terms of getting the plastic to stack better and not warp.
Yeah, exactly. So as I said, the whole magic of what we do really lies in the wood fiber we put into there. Of course, it's a combination of things, but things change a lot when we start adding with wood fiber. Also, what's interesting here, it was not something we actually aimed for, because we had to go, okay, what we printed plastic, it looks very plastic-ish, what we did. Mm-hmm. When we added wood fiber to the mix, it completely took the plastic out of the plastic. And the factory, when we print now, it smells like a wood factory, and what comes out of the machine looks like wood, and it feels like wood, and it behaves like wood. But actually, it's a large degree of plastic inside still, which actually which works in many ways. You can say this kind of the binder keeping things together, what's actually make the thing kind of stick, and then the wood fiber works as a thing that actually enable us to make nice layers, layer heights. It makes the print stable and so on. Tons of stuff in there. But that to broad terms, that's actually what's happening. That's the two kind of functions the two materials have.
Yeah, I have so many questions. So what printer do you use?
We have, at the moment, we work on a gantry rig. We have a big gantry rig here with a print field or print space of 6 meters times 4 times 4. So, and also I have to say that everything here is printed in a factory. We don't need to print on site. It's all off site in a factory. So we have this big gantry printer, which we can't design. We can't design it ourselves. Had somebody build it for us, a Danish company, which basically does large steel and medium type of structures. Put an extruder on there. We are working with different kind of extruders, and it happened to we thought it was our first production rig. It happened not to be. It happened to be a pilot rig, because what happened also when we put the wood fiber inside into the mix, it totally killed speed. We lost 80% of capacity of speed because it's just way tougher for the extruder, for the screw to kind of process suddenly a material where you have a lot of wood inside. So we had to kind of also redesign the next extruder we were working with. And now when we go into sort of manufacturing mode, that's where we are now. We are about now to go kind of commercial. We're still considering. We can still work on a gantry, but we're also considering doing robotic arm. The benefit of robotic arm, in many ways, we just have down the road more freedom to even cooler design, because we have more angles to work with. That's the main advantage. And we also kind of feel that the stability of the rig, as we called it, is better. In terms of having less or no vibrations, it's better or easier to control with a robotic arm compared to a gantry. Of course, if the gantry is big, massive, lots of steel there, fair enough, you can make that kind of stable too. But maybe we're looking more in the direction of a robotic arm, like many others do. But we started with a gantry for, I don't know why, basically. My co-founder said, well, the way I want to go. It's also the one which we could kind of afford at the time. So many parameters in there, being a startup, being, as by scrap up, what scrap is scrappy. So, and we had to be the same. And that's actually, for us, was a good place to start.
And the material, oftentimes plastic for large scale extrusion, is delivered in little pellets. Do you manufacture your own pellets with the wood inside and melt them down when you print?
No, we have that done kind of outside the company. So we get pellets in our compound, our kind of formulation. This amount of polymers, this amount of fiber. So that's compounded externally as a company which does it for us. We tried to. Everybody told us it's not possible. I said, well, I will show you. But we tried to kind of blend in the extruder. It didn't go well. So we figured out, okay, we have to compound the pellets kind of, outside, and then bring the pellets in, and they are those we then put in the tank.
Sure.
And everything is then done. The whole melting of the thing is then done in the extruder. So down the road, I see us doing that ourselves, getting the waste polymer in, kind of in flakes or pellets, whatever form they have, having the wood fiber, and then do the compounding ourselves. But the moment we decide to leave that outside, the company which does that for us.
And it sounds like at the moment you're doing a lot of testing, some experiments, and are you at commercialization yet? Do you have customers? Are you selling stuff?
We're selling stuff. We have we don't have a product out, a real product, a commercial product out there yet. That will come at the end of this year, over summer, end of this year. But we are now having pilot orders coming in both from Denmark and actually also from the UK. Nice. These are places where we're operating. We have some orders for kind of, I call them, small private customers who want, a kind of a large holiday house kind of thing in the at their own site. But these are not really the customers. Where we want to go, we want to deal with developers, because it's really about going back to the impact. The more product, the more homes we can kind of ship out there, the bigger impact we have. which means we have to work with developers who want to basically build, a city over here or 200 homes over there, or make urban densification, whatever they do. So we have volume, because it's really about getting the volume out there. So the more product we can ship, the larger impact we have in terms of not having homes built the way we do it today. So we really have kind of volume kind of strategy, which we put forward. And you say that might you can say, okay, that might delay the sale in some sense. Maybe we don't really see it, because we've got a lot of interest from the market what we do, because we check a lot of boxes. We check the box about affordability, check the box about sustainability, check the box about dealing with waste and all that. Everyone's asking, of course, is this really possible? And for that reason, we had to very quick as possible make a first prototype to show people that yes, we can actually print in this scale. And we have that in our factory. We have a full-scale prototype of one module sitting, and we are now working on the next one in another design. But that actually convinced people. And then, of course, we have tons of tests done in Denmark. We're a Danish company, as you know. We these different kind, accredited institutions who actually say, okay, stiffness and strength and what have you is good. It actually delivers on these parameters and so on. All that is done. All that documentation is extremely important to have. And we've done that. You kind of, on the side, while we were also kind of developing and building on the product. So we plan to and see, will we go into kind of commercial mode by and start delivering out there in the world by sort of Q3, Q4 this year on the first pilot projects.
Wow, that's very soon. And
yeah,
the mixing process, the pellets go into the extruder, you said, or they go?
Yeah.
Wow.
Yeah. So we have a tank, basically. That's traditional. We have a big tank. We put we get the pellets in big bags. That's put on top of the tank. That tank is then kind of attached to a dryer, which is kind of like a kind of vacuum system. It's kind of transported from the tank into the dryer, which takes out whatever humidity might be in the fiber and in the polymer, in the compound. And then there's kind of, again, same vacuum system, kind of transported on like flies blown through those pipes into the extruder, which prints basically on the thing. But it's one integrated system. So when the extruder says there's a little hopper there, which a container which keeps pellet, while it produces, we'll say now I'm half full, half empty, whatever. It triggers a signal, and then it kind of ships in more material, which from the dryer, which has its own tank, and the dryer then takes fresh, you can say, on-dried material. It is dried, but on-dried material from the storage tanks, and that's a continuous process. We don't need to do anything there, but press start on the dryer.
What happens without the dryer? The water boils and leaves bubbles or something?
Yes, exactly. When we started, we didn't have a dryer. We had these kind of small, explosions, you can say. And we could also, not like we it's only sort of poof and bang and so on.
Boiling water.
Boiling, exactly. And we could also see it when we took specimens out and kind of cut through them. There were holes in it. So it didn't have the same kind of structural integrity as it has now, where it's totally solid. So we had the dryer is really essential. People in general do not think that plastic can absorb water or humidity, but it can. Of course, wood fiber, it gets kind of, worse in that regard. Just soaking out kind of humidity from the atmosphere.
Yeah, like wet Cheerios.
Exactly. Exactly.
So,
nobody wants that. Nobody wants wet Cheerios.
So Denmark has some good programs for grants and startup funding. Were you able to take advantage of those?
Yes, not too much actually. A little bit. We have what's called the Danish Innovation Fund, and we got a smaller grant there in the about say 100,000 USD kind of area. So it wasn't very much. And then we have some other grants not kind of real money, but where you get access to these kind of accredited test institutions or universities who then do test job, development jobs with you. The way it works, we say, can we spend so many hours? Our hours is worth whatever per hour. And that's then via these kind of grant institutions and the EU transferred into money, which is then goes to the university or the test institute or wherever. That system actually works very well. We worked a lot with the Danish Technical University, DTU, and the Danish Technological Institute as well. On say on the back of these programs, getting cash in for ourselves hasn't been very much, but we've got some from the Innovation Fund. And the problem is it's cool with grants, definitely. The problem is it takes forever to get them. Really, and I mean that it's doing the application. Fair enough, it's free money. It got to be done kind of thoroughly, and they also give the money out. Got to be sort of pretty kind of sure does the money actually end up where that's supposed to end. But the backside, the drawback of that is that it takes forever to do the application. Then you get the money. If and as a startup, and I think in any business, we just don't have the time, the process time, which these kind of funds and institutions and even universities have. They have all the time in the world. Process and going to the stuff very academically. If as a startup you want to get out there, going to push product out, you don't have that time available. So it's just been a combination by really pushing hard, being very scrappy, being very effective on site, and then get in grants where we could get them, and then make the universities and technological institutions do their work, on our behalf and with us. So I think the irony is, in many ways, if you are a big company and you have more resource, and you just have a running business, then these grants, also some bigger EU grants, also can be very kind of useful. And you're still an SMB, so you're still a small company, but you're not a startup anymore, maybe. Because then you have the resource actually and money to survive while the process is going and the application process is on. And you can also apply for more money at the same time. So I think it's really about, I don't think these grant programs work as good as they could do, but definitely they do help. Of course they do. Another thing which is a bit controversial, which I used to say, when you look at the venture market for, say, Denmark, for Scandinavia, because we have so many grants and the general kind of public opinion is, well, that's very good. So you basically probably that takes a risk to put in the money to make these sort of startups get off the ground. That in a way makes investors, angels, so on, less risk prepared. So and the funding being out there locally is actually small, because also, come on, you get your money from different kind of grants, institutions, and so on. So in that regard, to me, it actually works. Opposite than maybe what was the intention. There also we see many startups actually go abroad for getting investments. The startup community here, or the investment community, that try to kind of be more competitive, to do better deals and so on. But the competition is fierce, particularly if you are in a startup which has some big ambitions. You see those who really succeed. They are those who go abroad and raise big money if they cannot do it via orders. That's of course that's the best route. You can come to a point where you can get orders in very quickly and start with finance via orders, and it also helps you get finance anyway if you need extra, because then you can show this order. There's actually folks out there who think this is a good idea as well.
Yeah, those are kind of two very conflicting points you bring up, in that the government could more easily give out money, or also the private investors sometimes handle it on their own.
Yeah.
I like the second one.
The private one? Me too. Yeah, because I think you if you have private money in, you move faster. Basically, to me, I kind of find it easier, which is also weird. but I kind of find it easier to attract private money. And it definitely makes you as a company, as a startup, move way faster than being part of some public program which takes forever just to get into, and then also to kind of work in. So yes, so in many ways, I think that's very kind of, you can say, maybe Scandinavian approach. Not mine, but the one which is general kind of out here, and the American approach. I'm on the American side here. Let's go out and grind, basically.
Another good
And
argument for it is it can be more personalized that way because it's a one-on-one relationship versus a one-size-fits-all program trying to determine who deserves money out of thousands. The investor can determine their own due diligence process, their own parameters to examine, whereas the grants have to examine every parameter for every group.
yes, that's actually a very good point. I haven't seen it that way before, but that's actually true. That is true. And you do, if you are good at speaking to people, getting out there, telling the story, these kind of one-to-one relationship we have, that's actually which drives you through. So that's correct. Where it gets more kind of anonymous in some public system. That is true. Absolutely true.
So, what's your entrepreneurial journey been like? Is it all spelled out on your LinkedIn profile, or is there more to it?
Yeah, well, a lot is on the LinkedIn profile. My personal, like, also even before, I've been an entrepreneur, I've been in startups, for a very long time. I said I started actually in chemistry, which was, big chemistry, big English company, was there for sort of 10, 11 years. And then from there on, I had 2 years in IT, also as being employed somewhere as a Swedish IT company. And then I started being an entrepreneur, doing first in kind of, communication, consulting, design, started a design company, then I've started a co-working space. So last 20 years or so or more, actually being an entrepreneur. The biggest thing I've been on, that's like what I'm doing now, Vorn, where we can do real impact. Being sort of having a startup, you do a design company, design agency, so on. It's all cool, it's all nice, but it doesn't have the impact of what we potentially can have in Vorn. And what's really really driving me, being this kind of starting, running a purpose-driven organization, really being on a mission to change the world, and we believe in that. We believe we can be one of those things that can change the world in terms of solutions to avoid climate change, to fight climate change, and also so how can we get more equality or fight inequality in the world. That's what really really drives us. What's been interesting here, talking about LinkedIn, when we started with we used my LinkedIn profile because I have a good network. I've been around for a long time. And then we start building the LinkedIn profile for Wohn, which now is stronger than mine personally. And I think, of course, it goes, we are in industry, people see we're doing things here, we check a lot of boxes, that makes it interesting for people to do. And then, of course, having these big machines, big prints, and all that, it is a very photogenic product. So we're pretty good at that in making kind of both some memes where we make fun of ourselves in one way, but also showing now we are here, this is cool. A thing which I find, what I often see on social platforms, and all like this, that we are humble of this, or I'm admired of that, whatever. No way, we don't say that. We say we just think it's extremely awesome what we do, and we love it. And we have a very kind of in-your-face approach, and I think also how we are as people, like we really, the enthusiasm, the joy of doing what we do clearly kind of comes across the table. We reckon, and that's also how we kind of behave and move around on LinkedIn, and apparently it works for us to do it in that way. So we've also been very deliberate in terms of how can you get publicity. How can we get in the press and so on? How can more people to know about this? That till now, but it's changing now. But till now, we have deliberately gone towards more kind of LinkedIn a lot, but also technical press. Technical press publications, like also podcasts, like yours, like this one, showing the technology of what we're doing, talk about the mission, what we're doing, but not doing kind of traditional so a channel which kind of say normal people read or listen to, but it was too early because we could end up having a lot of requests. Because we get that. We get a lot of requests already. We get a lot of requests of people who want to buy a home and wouldn't be able to deliver. So we'll spend an awful lot of time there having no product. Now it's changing because we're now going to commercial mode by set behind Q3, Q4 at the end of this year. And we're now opening up for the more kind of, say normal press. We had TV was here, the Danish called Channel 2 was around here last week. We are actually publishing now stuff also in UK and Ireland via magazines there. And get a lot kind of press attention now, also what you could call more kind of, consumer domestic type of press, non-technical press. Because that's kind of the next level we do. But we've been very deliberate holding that back till now, because we want to say we do technical stuff at the moment. We think it's cool, and we want to share that. Next step is we now talk to the folks who actually go to live in our homes.
Yeah, that makes sense. I guess you're still developing the technology and still building out your team. You mentioned you're experimenting a lot. What do you need the most right now to grow and expand? We need
I think if we land those pilot orders, definitely that's the first thing. We really need, and we're very close of doing that. Then we need engineers. we need people. I'm a commercial background, so I'm not very useful on the technical side as such. I've been on the commercial side all the time. And my co-founder Matus, who is he's the engineer in our team, and we need to clone him, multiple times. If I could clone Matus, that'll be great. And that's what we got. So we need more engineers who can actually work on, when we do new designs, work on the statics, is the construction, is the construction security, as it's supposed to be. We need then, of course, also, you can say machine operators, because the cool part of what we do, of course, is when we know material composition done, we have the manufacturing kind of system also in place. We know how to do this. Then it all comes down to the code, to the code, little piece of code, the G code, which can actually in theory stick into every machine. Which means, and you don't need many people for that. And then, of course, we can say the load-bearing structure is printed. Then we need craftspeople coming in to do the fittings, to make the home like a real home. And that can be done via two ways. We can do it by ourselves, have our own people doing that. That could be one route of going, or we can actually sell to, or so you say, engage with other kind of people who does fitting, so craft people who can do that. You can put in a door, put in a window, put in so like real floor on our kind of 3D printed floor, and so on. And we could go both ways there. But like in the core team, we need more engineers basically to work with this, to work on the kind of structure, do the calculations and all that, and then machine operators down the road as well. But the point is, we have to print 24/7. You can't stop the print. You have to go on till the print is done. So we got to work kind of 3 shifts. But if actually a machine operator, you got one guy, looking after 6 machines, 10 machines, whatever, it doesn't matter. So long, ideally that person shouldn't do anything, because if he has the most kind of boring day in the job because not doing anything, then the machines work. Everything's fine. We don't need to adjust anything. So, and that's what we can see here. We have a lot of control now actually what we're doing. When we started, we were down, next to a printer all the time, adjusting the layers and trying, optimizing, change a little bit here, fix a little bit there. Now it's running. We're just here because we have to be here and check. Still everything's still okay, and it is. So
you're not married to one business model yet. You might operate the printers for developers. You might sell the printers.
Not the printers. No. We the business model is we print homes. That is the business model. We print homes, or you can say we print load-bearing structures. Let's put it that way. We print load-bearing structures. That's what we do.
That's really significant. the difference, because the printed concrete is never the load-bearing structure in the projects I visited. They have poured columns, so they need rebar, all the other steps that you need. It's basically just permanent formwork. So
Yeah.
you're load-bearing.
Yeah, we print a load-bearing structure. They'll say, I don't know, like those who just watch this, listen, can't see it, but this is what I'm putting up is an image of, a model, a small 3D model of a house. This is a load-bearing structure we do. This is what's printed, and that's the one we can either finalize it ourselves and sell it to the developers, or we can somebody finalize it for us, some craftspeople finalize it for, put in the windows and doors and what have you, and then ship it to the developer. Our customer is a developer. Those who develop, this plot of 200 homes somewhere. That's how it is. So the system we're developing, you say the manufacturing system, that's ours. We don't sell that, but we sell the products as a system, the load-bearing structures. That's actually what we sell, and we could also sell the finalized house. Is that what the developer wants?
And you print them off.
Here, sorry.
You print them off-site and deliver them.
Yes. Yeah. Interesting thing here is, if you see that level we are now, we're still sort of small and new. If you have a developer who's used to build houses and develop, homes around, they in many ways have way better purchasing power for getting stuff in their windows and floors and stuff like that than we have. So it's actually a better deal for everybody if we ship the low-bearing structure, the shell. That's what we do, and to them. Or we make some kind of collaboration. Okay, this is actually the developer we're going to deliver to, and you do this, we do that. That's also a way of doing it. But our expertise, that is in printing load-bearing structures, is not in fitting a house. That's not our expertise. There are people out there who are way better in doing that than we are, you can say, or has done it kind of forever.
Yeah, construction's kind of naturally fragmented, so each subcontractor has their specialty, and that's really all you're responsible for, as long as there's enough space for the next guy to fit his window in or door or whatever needs to go there. Yeah.
What I would like I could see Wohn be our own developer down the road. So we basically take the full value chain, actually have a finalized house out there, even maybe owning the land, owning the homes, and then rent it out to a group of tenants, people who live in them. That could be one of the end games we're looking into. But the point is there, then you have the full value, you control the full value chain. You don't have, we want to avoid all these middlemen in order to make it affordable. And it also means you're going to have kind of 50, 60 years of recurring revenue on that home you put out there.
You can hold the financing, the insurance, the utilities.
Yes. Yeah. And the cool part about doing real estate is actually financing in the construction phase is kind of, that's the thing out there. That's what people do. So we can actually take, use the future homes, use it as collateral for the process, for the construction process we're having. So I could see us go there actually very quickly. Right now, again, being a startup and so on, we have to be careful not to work with too many. We have enough moving parts already. So it might actually be that we would rather sort of deal with somebody who does the finishing and fittings of the home, and then it's delivered to a developer. They're
Did you have any communication with the University of Maine team?
No, I know them. I know because I know I've seen they're the only one I kind of know of who does close to what we do. And they put a house out there, made of I don't know if it's upcycle or what, but polymer and wood fiber. Yes, and they have this huge 3D, so it's huge gantry printer. I've seen that, like gigantic, yes. So no, I have no contact, but I know of them definitely. But the only one I kind of know who does close to what we do.
Yeah, I don't cover university projects. I really only cover the private industry. Yeah. And that's mostly because there's just so many private companies. I haven't been able to cover all the companies I want to, and I focus on a niche. That way I can cover it well rather than trying to do a little bit of everything. So I haven't talked to those guys, but it's interesting. It's definitely a little bit similar in the same realm of 3D printed construction for homes, but avoiding um, concretes, using polymers, using wood fibers. Uh, that must have been a big, because they got a lot of media attention from that home. Was
Yeah.
there a big increase in your like Instagram follows, web traffic?
Um, yeah, in a way that was, on LinkedIn, we zoomed in on LinkedIn at the moment, but it's more
Mhm.
people kind of, tipping me, say, have you seen Morten? This is actually going up over there. And when you got the first one, or second one, and the rest one, yes, I have seen it. I've seen it. It's on. I'm, I have, I don't know if people, other folks did the kind of the connect between us and University of Maine or such. I'm not sure. But I'm having said so, again, we have quite a big kind of range of followers. We have the number of impressions we do when we do post things. We have people coming in now where I have no idea where they're coming from. And that's of course, the kind of say the dissemination, the way the post kind of spread and grow. Uh, uh, um, is working, you can say. So we have a lot of followers now where I have no idea where they're coming from. Well, that's the cool part. That's where you want to be. Actually, they have so much sort of traction and attention. So you can say the algorithm on systems
Yeah.
like LinkedIn actually does the job for you. So and that's that we came to that place very quickly. And again, I think it's because it is cool what we do. It's a new industry. We check all the boxes. It's very photogenic. Had it been software, you know, it's not very photogenic. We can show a computer and some code. Okay, cool. So I think that has helped us a lot actually in terms of getting this kind of load of followers out there. Again, being this very young startup as we are.
Yeah, those algorithms are powerful, and it's such a better form of marketing than paying per click or some advertisement people get irritated by. They choose to click.
Yeah, indeed, definitely. That's true. And again, also talk about your business model. We have attracted because we choose LinkedIn and the algorithms kind of work for us, and we're very kind of selective on where do we go in terms of sort of market appearance, who do we speak to, and so on. That has attracted the right people in terms of developers, in terms of you can say other kind of stakeholders also from other parts of the industry say, can you also do this, or can I be part of this because I have this kind of skill or ability I want to add into to the mix. So that has really worked well. Of course, you go out ending up selling your own homes to somebody, and we own them and we have tenants, people living in them. Of course, that's another kind of marketing regime you have to start with. Then you have to really kind of tell the world you're out there. But having said this, I'm surprised. I've never been in a field before where the demand for affordable homes or demand for the product here being affordable homes is so infinite. Never been in a place like this. And the crazy part is nobody can meet that demand. The demand for affordable housing is just so big that no one company can meet that demand anywhere. And it's really, really crazy. But that's how it is. But I think I don't know, affordable housing as such, of course, it is hard to build cheaply. And that's the reason why we went this kind of alternative route of doing this. Because everyone's okay, you want to make affordable housing, you can just lower your prices, but you can't because it's the way we are building today in general, and not us, but your builders out there, is slow, it's expensive, all kinds kind of problems in there, dynamics which doesn't really work to the benefit of doing something affordable. That's the reason I say you have to look some other place to make things affordable, and that's been real driver for us to go that place. And again, the demand for affordable housing is infinite. It's absolutely bonkers. What the demand is. Take a country like UK as an example. UK produce some 250,000 what they call starter homes kind of affordable, small, affordable, tiny living, smaller houses, smaller homes a year, 250,000. There's still demand for another 50,000 homes, which is unmet. So those 50,000 homes demand, which is unmet, is just accumulating, over the years. And again, no one can kind of meet that demand of affordable housing. No, like no one. And that's just one country. That's UK. We had a meeting yesterday with some from Australia. The same thing there. The Ireland the same. Well, it's all over the place. Demand for affordable housing looks differently all over the place, but it is the same problem. But of course, affordability is also kind of more dynamic thing. What's affordable for one might be affordable for another one, depending on what country and region you live in. But the whole notion of having access to affordable housing is a problem all over the place.
Do you ever think about what might happen to all of the mortgage-backed securities if somebody finds a way to build houses for $10,000, let's say, a respectable house for $10,000, say 100 square meters?
Mm-hmm. 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 I don't know. I think those who kind of have a mortgage today on on the traditional more expensive house, yeah, they will come in problem. They'll have might have a problem in a position where say they can't actually sell and get their mortgage back, or they have to live there till the mortgage is paid off, and then they might sell, and then with a loss and so on. But that's true. The existing market clearly will have a problem with if you have all these affordable homes coming in. But you can also say, and I guess that's what market forces, market dynamics is all about, basically. But I think for those making a new mortgage on an affordable house, that'll be way easier. Again, because the price you have to pay per month for living in that house, say you're a low-income family, a single-income family, it's way easier to get. I guess we don't have credit score rating type of thing here in Scandinavia, but I know we have in the US. And I suppose, single income or low income kind of family, your credit score is maybe not be the best, but it might be good and just good enough to get this little mortgage on a cheap, affordable home. I think if we come to that place, we have actually achieved a lot. Because it is about, fighting inequality, giving a better quality in life of people by having a decent home. This whole kind you call democratization of of things is democratization of having access to a decent home. We want more people to have access to a decent home than what's possible today. We want to democratize that.
Yeah, I don't bring up the mortgage thing to think that's a negative. It's definitely, affordable housing is probably the most important issue in the world, and it would be dramatically beneficial to so many people if they could get housing and it's affordable, even if it was $50,000 for a 100 square meter home. But
yeah.
I think it would impact the banks more than the individuals because, like you said, the individuals already have their mortgage payments. Those aren't changing, but some individuals would give up those mortgage payments for a cheaper mortgage payment, and they might even not want the house anymore. They might be willing to just give it away to the bank at a loss, and then the bank has the big deficit. Have you ever seen the movie Robin Hood?
Yes, yeah. Like
it's almost
from the Sherbet forest in
yeah,
UK? Yeah, sure, yeah. Different versions, but yes, I've seen it. Even as a cartoon, I think.
Almost like the ultimate steal from the rich and give to the poor. It's like leaving the banks with this debt burden of these overpriced homes that they lent on, if it works out and pans out.
Yeah, I haven't seen it that way, but I like it. I like it.
I don't think there's a bigger scale way to deliver to the people from the banks.
No, that is true. That is absolutely true. I think wouldn't the bank though have one say? I guess I have some kind of tie to the person living in there. So if you don't pay your loan back to us, then we go after you. But
Well, in America, the only thing they can take is the house. So
yeah,
the person can't be put in jail, and they can declare bankruptcy, and 7 years later, it's not on their credit. Uh,
yeah,
there's not
yeah.
much personal responsibility.
No, that's true. That's true. That's true. Again, I guess here, if in I don't know, I only know that the Danish legislation. If you go, you don't want to go personal bankrupt. That is not good for you because you kind of it is you're carrying it with you. Kind of basically for the rest of your lives. There are systems where you can kind of get out of that kind of trap. But if you say in the US, like you can only be personal bankrupt for 7 years or so, then you're good.
You can run
Oh
for
yeah.
president after that.
Yes, exactly. You could do that. Yes, yeah. You might get some folks voting for you on that one. That's true. That's true. So yes, but by and large, it is about the housing market as such has in many ways just gone off the rails, year after year after year after year, and with increasing demand, prices increasing because of that, people being pushed out of neighborhoods, people never been able to get in to having a house. I remember I'm 55 years old. When I was kind of 20, my wife and I, we could actually buy a 3-bedroom home flat in Copenhagen, and we bought it for nothing at that time. Today, my kids, zero chance. They can't get into that market. Uh, which means what they do now then when they study, they share a flat. There are 2 or 3 kind of folks living sharing a flat. Then they can afford it. And again, when my wife and I, when we kind of got married and we were still studying and all that, we bought one because we could. No chance today. So I did one thing wrong there. We sold the flat and then we moved out of the country in a place where we don't own the house. So that's kind of so we actually privately. I'm on a lease. I pay rent every month. I don't own the house I live in because we couldn't buy that house we wanted to live in. So I could say, man, have you kept that flat in Copenhagen and so on? Then we've been on that kind of journey. But that's the point. That's the journey I want to kind of fight. Actually, this is about giving fresh people coming fresh into the market an opportunity just to get a decent home because they cannot do that today. Not even, you can say, in a sort of very wealthy country like Denmark, like the Scandinavian countries and so on. It is super hard.
So on that note, have you put any thought into the design of your own Wohn home?
Yes, we have, and I have. It ties in a lot of 2 things which kind of goes into answering that question. One thing is about the footprint in the world, the carbon footprint, the footprint in the world we do as human beings. Back in the day, it was a lot of prestige having this big house, many square meters, square feet, whatever metric we work in. And the bigger, the more successful you look. And I think to me that's fundamentally wrong. And also, we don't have the space for it. And also, when you see urbanization rolling as it is now, 200,000 people move to a kind of urban environment every day, just like I'm floating in. There's no space for them. So we gotta learn to live what I call smarter. We should think more as a home. How many meter cube is your home? So basically, use a full space, use a full kind of you can say footprint or the full space of the home rather than just how many square meters land do you occupy with your home, being single story or multi-story. So the way we thought it into Vorn, actually, we see the Vorn homes are, in general, no bigger than 60 meters square. Could be one metric we put on it. They would be, by and large, 3 modules. That's the maximum. We'd like it to be even smaller. And we would actually rather talk about meter cube. The lot be 150 meter cube. That's the size of square. I still talk meter square because that's what people understand. But I would like to be the one who can actually change that kind of the language, the lingo we use behind that, and talk meter cube rather than meter square. We have in Scandinavia something, it's called a hems in our language, kind of mezzanine bed, elevated bed, not a bunk bed, but just elevated, which enables you actually to utilize again the whole space your home kind of occupies. And that's
Hmm.
where you can actually work smarter with the space you occupy in your home. And then again, utilize your space more efficiently and having kind of smart solutions, smart furniture, whatever, doesn't make this square meter cube as efficient as possible. It also goes well, and I think the point is, despite me saying this or not, it is happening because what you see, you have urbanization as one trend rolling, which I think is a very positive thing. People move to cities. That's good from an environmental perspective, from a climate perspective. Basically, more people using the same kind of infrastructure, and you can this whole notion about rewiring outside cities, and actually that's a very positive kind of, you can say, side stream of urbanization, one thing. And then also the fact that we are more and more singles. In 2030, I think OECD, they predict 40% of households are based on single income families, which basically are singles. Of course, it could be a single mother, single father with kids. It could be that, but it's more in the realm of people just being singles. 40%, which calls for smaller homes, which are affordable because you don't need that space and you can't afford that space in general. Also, being just basing your income on one person. So all these things which will happen regardless of me saying we want the world to go in that direction. I think it's actually going in that direction. Homes are getting smaller. I think the notion of people understanding we have to reduce the footprint also of what we do. What we eat, how we transport ourselves, how we live, and all that. The whole footprint of us as human beings, we had to reduce it. And homes is one of the areas which we have to reduce as well. How big are our homes? So I think, say 10 years from now, there's more kind of with human beings. We live of prestige one way or the other, or how people look upon us. But if you have, I think it's more prestigious to have this really responsible lifestyle. I have a home of this little size. It's super cool. I have all the cool stuff in there. It's very efficient. It's nice. It's cozy. The footprint is low. That's more prestigious than having this big mansion over there, with all the cars in front of it and all the space is occupied, which I'm not using. That notion, I think that is changing. I think it'll be way more like really profound, say 10 years from now. And I can see it also when we look at my own kids, who span from their club around 20. They, of course, well, they have influence what talk about at home from me. What do you talk about over dinner? About sort of climate, being responsible and all that, but also with their friends and so on. The thing about being responsible, a thing about reducing your footprint. Climate change is a thing which takes up a lot of kind of mental space with them, and they want to work with it. All these kind of trends go in the direction that we will end up being more responsible. I might be, I'm kind of hopeful there. Some think, oh God, you're naive, maybe, but I decide or deliberately say, I insist on being hopeful actually on this. So, and I think that there are traces out there showing things are going that direction. We will be more responsible. We will reduce our footprint with what we do. Gerald.
Yeah, certainly. And I think it's a great idea, the wood and the plastics, to do homes that are a little bit more typical to a material that we're used to building in, a little bit softer than concrete. There was a company I saw out of Sweden, I think, a long time ago, Search Plus. They were using wood pulp with polymers, and they used acetone instead of a thermal process. It was a chemical process. They would mix it with acetone to make it liquid, and then the acetone would evaporate. Have you heard of that project?
No, I've not. That's interesting. I can see it work. I don't know how working in that environment, with the acetone, white spirit, basically, so I don't know how cool that is. But using a chemical kind of curing process, that's not a bad idea. No, I haven't heard about it, honestly. I think the names tells me something, but that's an interesting actual way of doing it. So what's that? Is that kind of is it also done like an additive manufacturing process still, or
I don't know.
it's more fasted, or?
I saw one article, and it was a link to like one of the worst websites I've ever seen in my life. And this was years ago. I haven't really seen it since, and I think
No?
they abandoned it. But I did hear that if they had scaled up the process, the amount of acetone evaporating would have eventually led to acetone rain. So it's not something you
Really?
want to
No,
do too
exactly.
much of.
That's the point. You're having this white spirit around, But the idea of having a sort of chemical curing process, that is interesting. It really is. Yeah, sorry, I went off the rails with got society and how
No, it's
cities
good.
and kind
We
of,
have
kind of, kind
we
of,
have the time. I'm happy you did.
yeah, that's because that's actually taking a bit kind of, that's the reason why we're here. We do this because we want to change the way people live in their homes, the notion of what is a home, also notion about how to manufacture a home, but definitely. And going back to, cultural additive manufacturing, we see additive manufacturing, 3D printing being, with the way we do it, a tool that what we can do, and also produce fast. But the point is, we can print. When you print, the cool thing about printing a factory, there's nothing new there. That's what the people today already with normal prefab housing. The only problem with traditional prefab housing, they build homes the way that they built homes the last 100 years. They just moved, inside instead of building outside. Same thing they're doing. It's not automated. It's hard to scale. Where here, where we use the automation processes of additive manufacturing, we can actually scale this very quickly because, as I said before, so long we have full control of our kind of, the manufacturing system and the material with which we print and build, it's all about a code. We have to stick into a number of machines, and they'll just be spitting out like a sausage factory these sort of load-bearing structures, the homes we make.
Yeah, I don't
We
think
used to
the
say,
environmental stuff's off the rails at all. I think that's a core benefit of the technology, and my audience in particular is interested in 3D printed construction, but concrete has a huge environmental impact. It's one of the biggest questions people ask is what alternatives might there be?
yeah. And we believe we are one of those alternatives. Seriously, we believe that. We used to, here, particularly in Scandinavia, there's a lot of, you can say lobbying and also like real projects going around about wood. We should go back, good old times, build everything we can do in wood. Cool.
Mm.
The point is, and wood is a great material. And I think you can build some house in wood, it makes a lot of sense. But to me, building, we have in Norway, a kind of type of skyscraper type built completely out of wood to makes zero sense. And so that, you should do the other materials for that. That might actually be where we should still, if you want to make these very big structures, that's actually where you might be using still steel and concrete for that only, but only there. And then use the wood, for decoration purpose. Because what you see now in Sweden, in the Baltic states, where a lot of the wood is coming from, the toll on the kind of, forest resource is big. They say it's sustainable, it's come from sustainable sources. They cut one, the plant three, whatever the number is. But it's I also hear the messages coming out of the woodwork, so to speak. Actually, the toll is heavy. Can we really keep up with producing new wood that in the rate we can't take it down? And we need the forest for being a carbon sink, of choking out carbon dioxide of the atmosphere and all that. So going back to everything's made out of wood, I don't think that is a solution. It's part of the solution, but it's not the solution. That's where we then come in, saying, okay, let's take the wood waste from when you do your wood thing, your floors, your furniture, whatever, all the chips and sawdust, whatever come out of there. Let's take that as a waste, being a waste stream, which you back in the day kind of burned, which is terrible because then you release all the carbon dioxide again. And let's take another waste stream like plastic. Plastic is a great product and great to work with. You use it many times. The problem just been we scrapped it. We tossed it away, throw it away. We stop doing that. That's another waste stream, and then we can print these kind of very nice structures with new designs, organic shapes, and all that. So we believe if we succeed what we do and we can scale, and if we can scale it, this could be a paradigm shift in the way we kind of build and construct homes.
I don't know anything about plastics or environment stuff so much, but I'm going to try to ask a couple questions about it. I imagine the plastics degrade with the number of times you recycle them potentially. So maybe there's different tiers. So like new plastics versus almost unusable plastics after however many recycles. With the later stage plastics having a bigger impact to the environment if you're able to still use them. Which level, I guess, on that spectrum are you guys able to utilize for your process?
We can used to say, to a background, they used to say plastic can be recycled or regrinded 7 times. You know, because
Okay.
if you about the carbon chains in the polymer, you can cut them to a certain number, and then they collapse. You see, you can say the degradation of material is very, very slow the first 7 times. It's very slow to go, and then it collapses. And if you say, that's what we say, we part of the process what we do, we take in the waste polymer that's usually being used once or twice. Irony is, it's coming from industrial resources, industrial waste. That's by and large actually virgin material. This has been cast into kind of panels or columns or whatever, scrap production which went wrong, all that. Then we take it super clean and say it's going to be used 1 time. So in that we have 6 cycles left.
Mm-hmm.
If you take post-consumer plastics, which you use for packaging or also packaging boxes for food or whatever, where the extremely big volume is, that might be recycled once or twice also, and then it basically goes out. Because in a casting process, when you cast material or you injection mold material, you need really, really kind of
Homogeneous.
clean, and homogeneous kind of material. So they can only be recycled so much. We can then take it. We can go in anywhere there, because what also happens, part of our process is, we have a house, say it has a lifetime 50, 60 years, that's what we say, then we take it back. And we can then basically strip it, whatever was the interiors in there, we will then regrind that. We'll regrind the load-bearing structure, going back to that, and then we'll kind of spice it up, you can say, with fresh waste, which means we can extend the cycles from being 7 on common kind of polymer up to say 9 or 10 times.
Wow.
And then we have this kind of life, a lifetime per cycle being say 50, 60 years. That's a lot of years we actually have in this material. But required we have this take back solution. What we will have. We have to be able to show, okay, which house, that house over there, is made of what polymer, and where is it in its life cycle. Well, you can measure in the compound basically how good is it. You make some specimen tests, you make some called fluid test, and out of that you can see, okay, how good quality is the polymer or the compound we're working with. So in general, polymers 7 times, that's a rule of thumb. You can kind of recycle it. And what we then do, we used to say we have this upcycling of material, the upcycling of waste into a high value asset, being a house, and then we recycle it, kind of forever, or at least 6, 7, 8 times after that.
Mm-hmm.
And in that process, again, we can't go across these value chains, kicking out concrete, kicking out steel. We don't need a foundation either, so no concrete foundation there. Also in the mix, so to us, it's first about upcycling and then recycling, and we can then recycle this composite as what effectively is we made, kind of forever, just spicing up with fresh waste. But plastic as such is a great product. We have just turned into a culture, society, a globe where it's use it once and throw it away, which is ridiculous.
Yeah, we have so much because it's a oil byproduct, right? So it's we have it in abundance, but I guess it's been abused. We've been abusing the abundance. What usually happens after the seventh cycle?
Um, normally today, even early on, it gets burned. People
Mhm.
use it for fuel. Your fuel in power plants. Fair enough, we get heat, electricity out of it, but we also release all the carbon in it. It's like burning fuel. That's a problem. We burn it, or we use it for landfill, where then slow deteriorates, and you have all kinds of methane kind of be generated because the degradation happens under low, oxygen, kind of in low oxygen environment, and where you have methane, have even harder, kill compared to CO2 in terms of the greenhouse effect and so on. So basically, we trash it. We put it in the oceans. We use it for landfill. We ship it around the world. Yeah, it's really really ridiculous what's going on there. You can say for us, what happens 450 years from now with our product, I can't tell. That I don't know. I have to believe that we will have a process at that time where we can, extend its lifetime, or we can burn it under conditions where we can capture the carbon, in the process, whatever. But nobody looks more than people look maximum 50 to 100 years ahead. We're well kind of above that kind of scope.
Yeah, I
Some
mean,
people also
just at the very least, you have one material for the most part, and it's the load-bearing structure. Instead of having wood, insulation, metal, all those different things combined when you knock it down in a pile,
yeah,
it's much easier to disassemble and have something valuable that's more homogeneous than
totally,
garbage.
totally. And you can say the also talking about your installation, it is this we do this kind of sandwich load bearing structure like everybody does
Mhm.
in this field. Um, we also actually use a waste. It's not our problem. A waste product as insulation. We call it wood wool. It's also waste wood, which then been turned into pulp. Is then been kind of fluffed up, you can say, and then it's kind of blown into these kind of channels in what we call the core. Also being a waste product, which means you don't use kind of fossil fuels to make the rock wool, the stone wool type of product, which also a heavy carbon contributor in the world. So, and it's all again this notion: go down and look for waste streams and reuse them, upcycle them into something useful, or recycle them to a minimum into something useful. And again, this kind of frame we set up around ourselves. This is kind of this is the area we operate within.
Are you able to print a roof?
Well, that's what we do basically, because the way we do a 90 degrees printing, not 45, but 90 degrees printing. So actually, say we print. Well, I can show those who watch on YouTube or wherever, they can see it. Where we print a pipe, print a pipe basically, print like this, 90 degrees up, and then we flip it. Then you have a house with a roof, with walls, with floor. That's how it's done. You cannot do that in concrete. You have an open roof. You have to build a conventional roof actually to make the rain not come in. So that's the other advantage with the material we're working with, is that we can make this totally self-sustaining load-bearing structure, which nobody else can do. And also the reason why it takes no foundation. It stands on large kind of screws, it's called ground plugs,
Mhm.
which is then put into ground. So you can put the plugs in, put the house on top, done. You connect to the grid if there's a grid, and you can take it away again. So we go in very areas where you can work with contemporary housing. It sits there for 10 years because then we know as a municipality we want to use that land for something else down the road. Fine, then we move the homes. And again, you don't need to cast a foundation. what you need with concrete housing and other housing. Because if you don't have that, it breaks. That's the great about concrete. It's very good, in the kind of, strength in one direction, but again, in horizontal direction, it's really, really poor. So you need to reinforce it and all that. So we got a request based on, of course, tragedy, the earthquake in Turkey and Syria now. Actually, how fast can you set up shop there? Because we now need kind of 50,000 homes for people, and are they kind of earthquake stable? Seriously, I don't know. We haven't tested it for earthquakes, but having one structure where it's not like walls are separate, roof are separate. If the walls start to shake during an earthquake, the roof falls down. It doesn't happen here. It's one piece.
Is it brittle?
No, it's not. It's not. It will get brittle if it's exposed to sunlight. If you don't maintain it, coat it, or have the structure, then you get some brittleness. It's actually smaller than what we had anticipated. We just got some test results back, and I think that's actually the wood helps in the formulation there. But our enemy, you can say, from surroundings, that's sun, UV, and so we have to protect it with you have to paint it basically, protect it for UV radiation. We like very much green roofs, which again both help you with insulation. That's one thing. It helps you protect against the sun. Because you have this kind of piece of soil on top, and you have this kind of rubber membrane. So you have every place you make kind of a green roof. Absorbs water. You move micro kind of diversity where the house is. You just move that to the roof and so on. So we try to look for these solutions, which has many kind of, you can say, solutions in itself, kind of baked in. And green roofs is one of them.
Is the material also UV cured at the extruder head?
Yeah, no, it's not. It's not. We thought about no, not UV cured at all. We thought about, should we use some UV agent in the mix compared to painting it? And at the moment we go the coating way. Right? We will consider, should we put some kind of UV kind of agent in there in the mix? You do that in other products. But we can do that. But we just need to then test, does it have an effect on the properties of the product? Possibly not. But we don't know that yet. But it could be a good idea. We have a guy on who has a kind of advisory board. He's not formalized, one to speak to. He comes from a very big kind of injection molding company. A German company in Denmark, and they used to make these boxes for beers. They say that they stand all kind of festivals, they stand out the water, stand outside, and they last forever because they have some UV kind of agent in their mix. It's injection molded, it's for another purpose and so on, but it works. So you can kind of injection mold. Sorry, you can kind of put in a UV agent in the mix, and it works. We just don't know what does it mean for the integrity of the structure. We don't know.
Since you bring up injection molding, if you wanted to have one model that you made 1,000 units of identical, wouldn't it make more sense to injection mold your material rather than doing custom stuff?
It would. It would. It would need a monstrous machine. Having this kind of one module is 20 meters square. You can say.
Sure.
But then just injection mold or even extrude it. One big, you're making one long pipe, and every whatever you cut it. Yes, exactly. You could do that. That we have that on the kind of, you can say, future or fantasy drawing board. How could this be done? Like really, really big scale. I don't know what amount of power you need to make that injection mold or casting or extrusion kind of work. You need an awful lot of power to make it, but definitely it should be possible. Because basically you're just making a long pipe. That's what we're doing. Long pipe. That's what we're doing. So yes, that'll be next year. Let's look into that. That's the next podcast. That's probably that's where we're doing that next episode.
Yeah, it sounds very difficult to accomplish, but it's hard for me to believe that if it got all set up and you just had them spitting out one pipe of house,
Yeah,
it could be insanely cheap.
it could, and fast, super fast, super fast. We believe we are fast. We used to say we can make this kind of 20-meter square module printing in 2 days, the low barrier structure, which is fast for that. You flip it, yeah. And if you have more kind of open ends, because you kind of put them together differently, we can even reduce that time. But yes, if you had this kind of continuous pipe, you can make that even faster for sure, absolutely. And you don't need even to make. You can make 60 meter square, whatever or whatever these kind of 15-meter long pipe. That's your house. It could be cool, absolutely cool. But as you say, it needs to, okay. You need them to go. This is it's one size. It's one size or one kind of one shape. But definitely, yeah, it must be possible. I agree.
It's been great learning about plastics from you and hearing your story about how you started the company, your other companies, and also a little hint of some of your future plans. Hopefully we can get it more into that in a future episode. But thank you so much for joining me today. It's really been a pleasure.
Yeah, thank you very much. It's been a pleasure. Thanks.
Is there anything we left out that we should touch on before we call it a day?
No, I think we're good. I heard. I don't know if that's you're planning doing a European trip. Is that right?
Yeah. This summer, probably towards the end of the summer.
That'll be great. When you do that, if you kind of come by,
I'll be in Denmark. I'll reach out.
That's what I mean. That's my point. Come and make us a visit in when you're by in Denmark. That'll be great. That'll be really great. That's what we'll be making the next episode.
I'll do my best to visit every 3D printed construction company I can in Europe, and I'll prioritize the people who have come on the podcast already.
Cool.
So
Yeah. Well, I know. Yeah, there are at least 2 or 3 other Danish companies I remember being on here. So yes, come by. That'll be great. No, I think we touch everything.
Have you ever collaborated with OmLab? They do some environmentally friendly materials too, printing.
Yeah. No, we have not. We have not. We 3DCP, do concrete. We know them, and we are part. You have what's called AM Hub, Additive Manufacturing Hub, which is kind of the organization, 8% of everything additive manufacturing in Denmark, in Scandinavia, in fact. And we met 3DCP there. But again, in many ways, we're completely different kind of paths and directions of what we do, but we use the same piece of technology. So we know them, and then we know a lot of people inside the AM Hub, kind of as such. But no, the other one's not.
Okay, great. Well, thanks again, and hopefully next time I see you in Europe.
Yeah, that'll be great. Good show. Thanks a lot. Bye now.
All right,
Cheers.
later on.
Bye-bye.